Hello everyone, good morning all. Before I discuss anything, I want to share some geometry. Number 1, linear. If metal ion attached with two ligands on only one surface, then the formation is geometry linear. And the second is, if the metal ion is middle and the three ligands are situated surrounded it, then the geometry is trigonal pyramidal. But the situation is these ligands are situated on two or more another surfaces. But if ligands are situated at only one surface, then it will be ट्राइगोनल प्लेनर। नेक्स्ट है आपका टेट्राहेड्रल। if the ligand is situated at the middle and the four ligands are situated surrounded by the metal ion, then situation created by the geometry is tetrahedral. And if the metal ion 1 situated with four ligands with one surface, then situation created square planar. Number 5, square pyramidal. If a metal ion surrounded with five ligands, then situation created and the geometry is square pyramidal. If metal ions surrounded by five ligands but the surfaces are different, then the ligand is trigonal bipyramidal. If the metal ion is surrounded by six ligands, then the situation created geometry is octahedral. Now next 7 is mu complex geometries. These are belongs to higher education, so we will not discuss about it here, but I will give you basic concept about it. It could be pentagonal bipyramidal, it could be capped betahedral, it could be capped trigonal prism. Next, same like as square anti-prismatic, and it could be trigonal octahedral also. Have a look on next slide please. Now we will discuss about assumptions. Number 1, metal. Our first assumption is metal is vacant. It could be S, P or D orbital. During the coordination compound, we will always discussing about only transition metal ion or d orbitals. But here in valence bond theory, we can discuss about s, p and d orbitals also. Number 2, suitable number of empty orbital undergo hybridization. That means hybrid orbitals. Look at this. Hybridization is goes to the formation of bonding only, and the formation of bonding is created between the same hybrid orbitals. That's why I am writing suitable number of empty orbitals undergo hybridization, and that's it, hybridized orbital. Point 3 है आपका the empty hybrid orbitals of plus m metal ion overlap with the filled orbital of ligand. That means if one metal has one empty orbital and our ligand have one lone pair of electron, we already know that if any metal ion have one lone pair of electron known as ligand. That's why I'm saying if a metal ion have one empty orbitals and another ligand have one lone pair of electron and we want to hybridize both of them, then it could be possible. What is this? It will be the ligands are transform or share both of two electrons or one pair as unpaired electrons to the one metal ion of empty orbital. Then the situation will be m bonded with the sharing electrons and ligand, and the geometry is linear. Next point है ligand are classified into two categories. as we know, there are three type of ligands, but here we will divide ligands into two only. Number one is strong ligand and number two weak ligand. But during coordination complex we will divide ligands in three parts. Number one negative ligands, number two positive ligands, and number three neutral ligands. So here we are discussing about strong ligands. Strong ligands are those who have tendency to pair of electrons, just like point 3. Strong tendency, that means they will bond up with the covalent bond, and weak ligand, it means they have weak tendency to pair up. We want to say that means they will pair up with the ionic bond. Next point is octahedral complex. Look, if I discussing about octahedral complex, that means here coordination number is 6. So if the central metal line of matter is situated with 6 ligand, then the hybridization will be two types. Number one, sp3 hybridization, okay, or sp3d2 hybridization, or d2 sp3 hybridization. When I am discussing about octahedral, then our hybridization is sp3d2. It indicates that our hybridization undergoes with the outermost shell of d orbital. But if I am talking about d2 sp3, that means our d orbital undergoes inside orbital or penultimate shell of d orbital with sp3 hybridization. So have a look with it. I am discussing about d2 sp3 very first. In d2 sp3 we are taking 5 shells of d orbital or lobes. We can say lobe also. One dxy, second dyz, third dzx, and fourth dx square minus y square, and last dz square. And we are taking one s orbital, and we are taking p3, means px lobe, py lobe, and pz lobe, and they are taking or undergoing hybridization. That means sp completely hybridized with together, and these two orbitals hybridize with z, dz, or dx square minus y square, and they formed d2 sp3 hybridized orbital. That is, if d orbital of inner shell n minus 1. If I am talking about inner penultimate shell, then we will discuss about n minus 1th shell. This is known as inner orbital complexes. Okay, that means if we are taking d2 sp3 hybridization, then the formed complex compounds are inner orbital complexes. Next situation could be sp3d2. If the situation is sp3d2 hybridization, then we are talking about s and p orbitals are undergoing together hybridization of sp3, and this sp3 hybridized with outermost shell of d orbital also, and we are taking in d orbital is dxy and dyz only. That is, the d orbital of outermost penultimate shell of hybridization is called outermost orbital complexes. The difference is, if I taking inner shell of d orbital, then we called inner orbital complexes, and if I take outermost shell of d orbital, then we can say outer orbital complexes. That's it. Next topic is, now we are discussing about tetrahedral. We know that tetrahedral shows two type of valencies. I want to know कि tetrahedral have same planar different planar geometry, and जो square planar is the same planar geometry. So firstly we are discussing about square planar complexes, that means square planar geometry. So metaline is dsp2 hybrid. Look, in the coordination number 4 we have two type of condition. Number 1, dsp2 or sp2d, right? या फिर sorry, dsp2 or sp3. That means if I taking sp3, that means geometry is tetrahedral. If I taking dsp2, that means geometry is square planar. So firstly, according to the hybridization dsp2, we are taking d orbitals very fast, and these are dx5, dyz, dzx, dx minus y square, and dz square also. But during the hybridization, we will hybridize with only dx square minus y square, not with the z square, because we know that the loops between the x square minus y square is on the surface, but if we are taking dz square, our loops will be on the axis. That's why we are taking dx square minus y square, and our s orbital and vacant p and px and py orbital. That means if they combine together with dx square minus y square, then they will form dsp2 hybridization. बच्चे आगे कुछ मैं बोलूं उससे पहले मैं आपको ये जरूर बोलना चाहूंगी कि एक बार अपना हाइब्रिडाइजेशन को आप रिवाइज कर लीजिएगा, जिससे कि मैं क्या बोलना चाह रही हूँ वो चीज आप प्रॉपर समझ पाए. अगर आपने रिवीजन नहीं किया होगा तो ये प्रॉब्लम आपकी रहेगी. नेक्स्ट आपका पॉइंट है 8. दिस थ्योरी इज बेस्ड ऑन मैग्नेटिक मोमेंट मेजरमेंट. BBT theory is based on magnetic moment measurement because this theory based on unpaired electrons of d orbitals. Number 1, if complex containing one or more unpaired electron, then the situation will be paramagnetic. I am repeating again. If a complex completing or containing one or more unpaired electrons, we are talking about d orbitals. That means in d orbitals, if we are taking vacant orbitals, then the situation is paramagnetic, and the complex containing only pair, that is diamagnetic. That means we are discussing about d fully completed filled orbitals. Okay, and the situation is diamagnetic. If we want to know about spin of electrons, or we want to know about magnetic moment of electron, they will defined by the mu s, and the formula is under root n bracket nn plus 1, and where n is the number of unpaired electrons and 2 is the simple number, and the unit is Bohr magneton, where n is number of unpaired electron. This is your topic, valence bond theory. And now we are talking about octahedral complexes. As before, we are discussing about octahedral and square planar also. So this is our last PDF and last slide. After this, we are discussing BVT part 2 with our next lesson and next slide. तब तक के लिए stay tuned, stay safe, have a good day, bye all.